All right, so here's what we notice. We notice that the roots could be nice integer locations at two different spots, but we also see it could be a single location. It could actually be no locations at all, or it could be decimal locations, possibly even irrational locations. So there are two ways that we are going to determine the x-intercepts. Now, really quick, the x-intercepts have more than one name. You might also hear them called roots. You might also hear them referred to as the zeros, or even the solutions. All of these words are kind of synonymous with each other in regards to what we're looking for. So if I want to figure out the x-intercepts or the roots or the zeros or the solutions, and I want to do that graphically, I am going to just look where the parabola let's get some better ink, where the parabola crosses the x-axis. If I want to do it algebraically, I'm going to set the equation to 0 and solve. Now you might say, why am I setting the equation equal to 0? That's pretty easy to understand. Let's take a look at this one more time. I'm looking for where the graph crosses the x-axis. What's the value of y anywhere along the x-axis? The value of y is 0. So if I take the y and replace it with a 0, I am going to be finding the x-intercepts, which we now know are called the roots, or the zeros are also the solutions. Now, we worked on this before we left school last week, looking into how to solve quadratics. So I want you to take these same questions from the do now, and now we're going to solve them algebraically, and I want to show you what happens. All right. So how do we solve quadratic equations? Well, the first way we could solve them is by factoring. We also have square root. We also have the quadratic formula. And we also have completing the square. So we could also complete the square. So there are a lot of ways that you've learned how to solve quadratics. Let's just focus in. Now again, if this is factorable, then we're going to factor that. Now this is factoring by AM method because it's a trinomial. And so this factors quite nicely. What two numbers multiply to -3 that add to +2? We would say that the answer is x plus 3 times x minus 1. And that should do it there. So now what we want to do, just like we were solving before, we want to take each of these factors and set them to 0. Again, the reason we do that is because when I'm multiplying two things to give me 0, one of them has to be 0. So I'm just going to figure out what makes these 0. So what makes this 0 would be -3, and what makes this 0 would be +1. Now, where did we say that this crossed the x-axis? At -3 and +1. So we get the same answer graphically, but we can also get the same answers algebraically. Common way to write the solution is using brackets, -3, 1. You may also leave it like this as well. All right, let's get into this next one. Let's try to factor this. If it factors, awesome. That's what we're going to do. So we have x squared minus 6x plus 9 equals 0. All right, what happens when I factor this? Well, what multiplies to 9 and adds to -6? We're going to have x minus 3 and x minus 3, which makes sense because Negative 3 times negative 3 is 9, and negative 3x plus negative 3x is your negative 6x. So if I split the middle, and I set both of these to 0, what you're going to notice is you're going to get x equals 3 for the first one, but you're also going to get x equals 3 for the second one. So we actually only have one root, which we saw from the picture. This is this one here. This is this one here where it only hits one time at 3. And algebraically, if I find the x-intercepts, I get the same factor, which produces a single root. All right, let's try the next one. So the next one, I'm going to have x squared plus 3. I want to set it equal to 0. Now, the problem with this one is it's not factorable. So I'm going to go ahead and do the square root method. The reason the square root method works very nicely is because there's no middle term. There's no b term. So I get x squared equals negative 3. And how do I undo a square? I square root both sides. Remember, anytime you square both sides, there's a plus minus. But what do we notice? What's the problem here? That's right. The problem is I can't square root negative numbers. I end up with imaginary numbers. So the final answer is going to be plus or minus the square root of negative 1 times the square root of 3. And we know the square root of negative 1 we represent with the letter I. Now you might say, okay, my solutions are I rad 3 and negative I rad 3. What kind of answers are those? Well, they're imaginary answers, which means these are not real numbers. And if you look at the graph, what did you notice? The parabola never touches what? It never touches the x-axis. So anytime we get roots that are imaginary, the parabola will not cross the x-axis. So that makes sense for this one now. Now we have imaginary roots on this one. And let's do our last example here. Now let's try to factor this. Does anything multiply to negative 2 and add to 4? Well, no. 2 is prime, so it's 2 times 1, and you can't create a 4 with 2 and 1. So this is not factorable. So we're going to go ahead and use our quadratic formula. So let's first off set this to 0. We're going to identify A, B, and C. So A is 1, B is 4, C is negative 2. Now, if you memorized the quadratic formula or you learned a really good song that one of your teachers made, we're going to have x equals negative b plus or minus the square root of b squared minus 4ac. And we're going to put that all over 2a. Again, why am I using the quadratic formula? Because it does not factor. These two factored very nicely. So let's go ahead and start plugging some values in. So we're going to get x equals negative 4 plus or minus the square root of 4 squared minus 4a, and c is negative 2, all over 2 times 1. Now, I like to evaluate the discriminant, 4 squared minus 4ac. 4 times 1 times negative 2. That's going to give me 16 plus 8 is 24. So I'm going to have plus or minus the square root of 24 all over 2. Just like we worked on last time, I'm going to break down the square root of 24. That gives me 2 rad 6. So that is going to be negative 4 plus or minus 2 rad 6 all over 2. And again, I can triangle reduce. I cannot reduce the square root of 6 with this 2. But I can divide all of these numbers by 2. So that's going to be negative 2, 1, and 1. And so my final answer is going to be x equals negative 2 plus or minus rad 6. Now you could split that into negative 2 plus rad 6 and negative 2 minus rad 6. But what's the point? What kind of a number is square root of 6? Well, the square root of 6 is irrational, meaning the x-intercepts or the zeros or the roots or the solutions to this quadratic are irrational. And if we go back to our example here, we notice that the best we could do is say it's somewhere between negative 4 and negative 5. and it's somewhere between 0 and 1. And look, the roots are these irrational numbers. Irrational numbers. All right. Again, you could plug this in your calculator and get 2 decimals. You're going to get a decimal in between -4 and -5, and you would also get a decimal in between 0 and 1. So you would plug in -2 plus rad 6, and that's going to give you this decimal. And then you'll do -2 minus rad 6, that will give you this decimal. But again, if it says what are the exact roots, we're just going to leave it like this. This is totally okay. All right, so here's our takeaway. The x-intercepts of a quadratic function are also known as the roots. They are also known as the zeros. And sometimes you might even refer to them as the solutions of the quadratic equation there. All right, so let's just turn to the last page. So this is going to be your homework. I mean homework, I put in quotes because it's optional here, but I highly recommend you do this worksheet. So what you want to do is you want to create a table of values for these 3, graph them on graph paper, draw and label the axis of symmetry. So this is going to be a review from yesterday. Then what I want you to do is identify the roots. In other words, tell me where these cross the x-axis. Then for these last 3, I want you to set them to 0, find the solutions algebraically. And then what you can do is you can always graph these, go to your graph, and see where it crosses the x-axis and match it to what you get here. The answer key to this will be under the homework section on the website. And you are also going to have your mandatory Castle learning questions. A few of you did not do that yesterday. Please, this is the way we are going to make sure that you're watching these videos and you're learning the material. Please do the Castle learning, and then you'll see the immediate feedback from that. All right, hope all is well, and we'll talk to you guys tomorrow.